Determining the maximum distance for a given wire gauge and type in an underground connection from a service meter pole to a residential service panel operating at 240 volts and 200 amps involves several factors. These include the wire gauge, the type of insulation, whether the wire is run with or without conduit, the depth of burial, and local electrical codes. Here is a breakdown of the considerations and some general guidelines. Firstly, let's consider wire gauge and material. The American wire gauge, or OAK, system is used to standardize wire sizes. Larger AWG numbers indicate smaller wire diameters, and smaller AWG numbers indicate larger wire diameters. For underground residential services, copper and aluminum are common conductor materials. Copper has lower resistance than aluminum, so it can carry more current for a given wire gauge. Secondly, insulation type is important. THHN is a common type of insulation for underground installations. THHN stands for thermoplastic high heat resistant nylon coated. It is rated for 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations. THHN is suitable for use in conduit and direct burial applications. Thirdly, the use of conduit affects heat dissipation and protection. Conduit provides physical protection for the wires and can also help dissipate heat. When wires are installed in conduit, they can often handle higher currents or longer distances compared to direct burial without conduit because the conduit aids in heat dissipation and prevents mechanical damage. Fourthly, depth of burial as specified by the National Electrical Code, or NEC. The depth of burial for underground service conductors depends on the voltage and whether the conductors are installed under a driveway or other areas subject to vehicular traffic. Typically, for residential services, a burial depth of 18 inches is required for direct burial cables and conduits. Fifthly, voltage drop is a critical factor. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source due to the resistance of the wires. Excessive voltage drop can cause appliances to malfunction and can damage electrical equipment. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To calculate voltage drop, you need to know the length of the circuit, the current flowing through the circuit, the wire gauge, and the conductor material. The formula for voltage drop is voltage drop equals 2 times current times length times resistance per foot divided by 1000. Where voltage drop is in volts, current is in amps, length is in feet, and resistance per foot is in ohms per foot. Sixthly, soil thermal resistivity. The thermal resistivity of the soil affects the heat dissipation of underground cables. Soil with high thermal resistivity will impede heat flow, which can increase the temperature of the conductors and reduce their ampacity, or current carrying capacity. Sandy or rocky soils typically have higher thermal resistivity than clay soils. Seventhly, ampacity correction and adjustment factors. The NEC provides ampacity tables that specify the maximum current that a conductor can carry safely under specific conditions. These tables take into account the conductor material, insulation type, and ambient temperature. However, the ampacity must be corrected for ambient temperatures above 30 degrees Celsius and adjusted for the number of current-carrying conductors in a raceway or cable. The correction and adjustment factors are provided in NEC Table 310.15. Eighthly, local building codes. Local building codes may have additional requirements or restrictions on underground wiring installations. It is always recommended to consult with a qualified electrician or the local building department to ensure compliance with all applicable codes. Ninthly, direct burial versus conduit. When burying wires directly in the ground without conduit, you must use cables that are specifically rated for direct burial, such as underground feeder or UF cable. UF cable has a moisture-resistant outer jacket that protects the conductors from corrosion. When using conduit, you can use individual THHN wires, which are typically less expensive than UF cable. Tenthly, example distances and wire gauges. Without conduit, firstly, 1/0 AWG THHN can span up to 300 feet. Secondly, 2/0 AWG THHN can span up to 400 feet. Thirdly, 3/0 AWG THHN can span up to 500 feet. Fourthly, 4/0 AWG THHN can span up to 600 feet. 11thly, example distances and wire gauges with conduit. Firstly, 1/0 AWG THHN can span up to 400 feet. Secondly, 2/0 AWG THHN can span up to 500 feet. Thirdly, 3/0 AWG THHN can span up to 600 feet. Fourthly, 4/0 AWG THHN can span up to 700 feet. These distances are based on several assumptions. Firstly, the distances are for a single conductor buried directly in the ground. Secondly, the distances are for a depth of burial of 18 inches. Thirdly, the distances are for a continuous run without any splices. Fourthly, the distances are for a 240 volts, 200 amp circuit. THHN is a common type of wire used for underground installations. It is always recommended to consult with a qualified electrician or refer to local building codes for the specific requirements in your area. The provided distances are approximate and serve as general guidelines. Always consult local electrical codes and a qualified electrician for accurate and safe installations. Consider voltage drop calculations, ampacity adjustments, and soil conditions for optimal performance.